Hey everyone, welcome back to another 7-minute math video.
When talking about systems of equations where we graph, it's important to simply know what you're looking at. Here's an example of two lines that are being graphed. This would represent perhaps the number of people that used to shop locally but is declining because of social distancing, and the number of people that used to, relatively low, number that used to shop online that is increasing due to social distancing. And at some point, these two lines are going to cross at a certain number of days into this thing that we're all living through. And where they touch, that's going to be considered our solution. Now, when we have two or more equations that we're dealing with, we have things that are called simultaneous equations or a system of equations, often shown with a pair of equations. And the solution is the point where the point that solves both equations, or the point that represents where the two patterns meet when they graph. So we're going to primarily be graphing and looking for the point where the two lines touch. It's worth mentioning that when talking about solutions, there are three possible solutions. The most common one is shown on the left, when I have two lines, both linear, meaning they're drawn with straight lines, and they intersect at one particular location. When they intersect at one location, they have one solution, and that one solution will be represented with two numbers inside parentheses separated by a comma. So whatever this solution would be, it would have an x value and a y value. Now, it's also possible that we have two lines or two patterns that increase or potentially decrease at the same rate. This one, the blue line, is going up and to the right, and this pink line is going up and to the right, and they appear to be going up and to the right at about the same rate. I would use the word parallel to describe those two. If I see that the lines are parallel, or that their slopes are the same, or their slopes are equal is another way to say it, then these lines are never going to cross. And we're going to have no point where they cross or no solution. And you've seen that in class in different examples already. So we have one solution where they cross once. We have no solution where they don't cross at all. And you can probably guess what's going to happen here. I tried to represent two lines, one being right on top of the other. It's a little hard with Sharpies. But what I do find is that if I have two lines where one is right on top of the other for the entire duration of the line, then we would say that we have infinite solutions. Sometimes there's abbreviations. NS is for no solution, or IMS, infinitely many solutions. That's another phrase. Kind of depends on who your teacher is and what language they use for the possible solutions. Since we're going to be heavily dependent upon graphing in this first chunk, it's going to take us through at least this first lesson. If you find that you need help graphing, I'm going to have a couple links at the end of the video that can help you. You can always go find your own as well. But I'm going to say that when we've been in class, we've been graphing using a table, and that is always a good strategy. However, it is a little bit of a tedious and sometimes time-consuming strategy as well. So in addition, I'm going to show you how, in those extra videos, how to graph using a slope and a y-intercept. This is kind of a one-use item. If you're a fan of Alton Brown, this is a unitasker. It only really works for one scenario, but most of what we're going to do is going to be that scenario. And that scenario is specifically when I have an equation written like that yellow poster of mine, y equals slope x plus y-intercept. So if I have anything written like this unitasker is going to be really valuable. It's going to make your graphing life much faster, whereas graphing with the table is just as accurate, but it's a bit slower. I have two scenarios for you. The first one is just straight math. It's an example problem that says solve by graphing. There's two different patterns right here. This is going to be a very common problem for you to work on, whether it's in your on an online PDF that I provide you in Get More Math, in Study Island, in any resource that you'd really find. This would be a very traditional kind of standard question. I'm going to go over the ins and outs of how to graph very quickly right here. Once again, there's extra videos if you need them. For the first equation, I see my y-intercept is -3. So on my y-intercept, I'm going to go 1, 2, -3 and make my first dot. From this dot that I've made, I look at my slope of 3 and 2. So that means 3 spaces up, 2 spaces to the right. So 1, 2, 3 spaces up, 2 spaces to the right, I make a new dot. Now there's no way to know if those 2 dots are enough, so I'm going to do it again. 1, 2, 3 spaces up. If I had graph paper, this would be a bit easier. 2 spaces to the right. I'm going to do it if I can. 1, 2, 3 spaces up. I'm kind of running out of space here, 2 spaces to the right. If I've done it correctly, I should have myself use your imagination there, a straight line. Should be straight. Now let's look at the second one. Same strategy, different color, but same strategy. Start at +1. So on the y-axis, +1, there's my dot. From that dot, I'm going to count 1, 2. Now these are both positive, so that's 1 up and 2 to the right. So 1 up and 2 to the right. I'm going to go again, 1 up and 2 to the right, and I got lucky. Notice how they touch right there? That means that if I were to draw a straight line, this right here, this point where these two lines touch, that's my solution. And the solution isn't the picture. This is the important thing. Drawing the picture is kind of showing your work. The answer is where these two lines actually cross. So these two lines cross from the origin now. Notice I counted from the blue or the red dot before, but now I'm counting from the origin. 1, 2, 3, 4 spaces to the right, and 1, 2, 3 spaces up. So 4, 3. That's how you do it. Now this problem doesn't have any negatives, but you can handle negatives and you can watch those other videos if you need. So scenario number 1, graph the two lines, identify where they touch, and mark down where that point is. Need some extra help? I mentioned that I was going to have some options here for you. You can click on some of these video links to watch how to do some of the things that I've mentioned, or you could subscribe, of course, and be updated when I post new video content. So good luck graphing systems of equations.